Welcome to Algebra 2, Chapter 8, Section 1. This chapter is going to be broken up into Section A and Section B. And for sure, Section A is going to have 2 videos to get us through it. So this is a long, lots of little different pieces of information in this chapter. So we're breaking it up into chunks. But the very first chunk, you should be very familiar with. Measures of central tendency. We are talking about mean, median, and mode. These are different ways to measure the center of data. And just to refresh your memory, try to remember what each of them are before I say it. But what is the mean of data? The mean, or the arithmetic mean, is the sum of the values divided by the total number of values. So I'm going to write that out. You might want to write it out too for your notes. Sum of the values divided by the total of the values. The total values. So add them all up, divide by how many you have. That's usually what I say in my head. The median, I remember that one by thinking middle. So in order to find the median, you're going to basically line them all up and find the middle one. If there's an even number, you have to take the 2 that are in the middle and average those. So the middle value, or the mean of the 2 middle values. So if there are an even number, I'll show you in a minute, and there's 2 of them, you have to divide them by 2, but you have to put them in order first. And finally, we have the mode, which when I say mode, I think most. So this is the one that occurs most often. So this one, you can have more than one mode. You can have no mode. If everything only happens one time, usually you just say there's no mode because there's nothing outstanding. And if there's something that repeats a lot, there might only be one. All right, so let's find each of these values for this data here. First thing you want to do when you have a big long list of data is put it in order. So let's start with, looks like 2 is the lowest number, and there's 2 of them. So 2, 2, 1, 2, 3 threes, 1, 2, 3, and then 1, 2, 3, 4 fours, 1, 2, 3, 4, and then 2 fives, and a 6. So you can kind of tell right now, we probably could answer the mode because I kind of counted them as I did it. So the mode is 4. And it's not because it happened 4 times, it's because the 4 is the number that repeated. So what number occurred the most often is definitely 4. All right, let's do them in order now. Mean. So for the mean, we need to add all these up. So add all that up. You can use your calculator if you need to. It's 45. And how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 terms. So this is by the total number of how many there are. You can divide those 2 numbers and you get 3.75. Your mean should be some number that is kind of a middle. So the measures of central tendency are different centers of the data. The mean is the average when you average them all out. The mode is the one that happens the most. It's not always in the middle. Sometimes it is, sometimes it isn't. And the median is, if you line them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Between the 6th and 7th, this is where the middle is. So since both numbers are 4, the median is 4. But if they weren't the same number, I would add them up and divide by 2 to just find what they are. So I'm just going to show that 4 divided by 4. 4 plus 4 divided by 2 is 4. This is easy one because it's just 4. And we already did the mode, which is 4. You'll notice all of these are close to each other. They don't always have to be. Sometimes the mode will be a low number or a high number. But that's a start for this. All right, second, we're going to go a step further. You're probably somewhat familiar with this. If you're in high school, your grades are probably done this way. So a weighted average gives greater importance to some values in the set than to others. So a lot of classes have tests weighted higher than homework, things like that. To find a weighted average, you multiply the value by its weight and then divide the sum of these products by the sum of the weights. So, for example, we have a teacher's class where the homework was weighted 30%. So I'm going to put 0.3 times her homework score, which was 84. And then the next weight is tests have a weight of 0.4, and her test score, or her test average, is 88. And then finally, we have the final exam, which has a weight of 30%, 0.3, and her final exam she got a 91, so that's good. So then we can add up all of these and divide the sum by the sum of the weights. Well, what do all of these weights add up to? 0.3 plus 0.4 plus 0.3. Usually it's 100%, so this is just dividing by 1. So we didn't have to. If, for example, if your final exam wasn't in yet, then you would need to divide these by 0.7 to figure out your weighted average. Anyway, so this is obviously going to be a calculator thing. When you are typing it in your calculator, be careful that you put an extra set of parentheses around your entire top and your entire bottom and divide them. Or in this case, you can just add up the top and it adds up to 87.7 divided by 1. So her score in the class right now would be an 87.7, assuming that's probably her percent. So that's a weighted average. Now the next thing you're probably not going to be as familiar with, this is called expected value. Let me find it. I have my wrong page. There we go. So expected value is the weighted average of all the outcomes. So instead of it giving me like a percent weighted average, it's going to tell me an expected value. So for this problem, this is the probability distribution for how many games it takes to win or to finish off the World Series. So you have to win 4 out of 7 games in order to win the World Series. So the probability of having only 4 games is 5 out of 27. The probability of taking it all the way to 7 games is 11 out of 27. So looks like most of the time we actually go all the way to the 7th game. This is usually because by the time you get to the World Series, you've got 2 really good teams. All right, so what is expected value? It's the weighted average of all the possible outcomes. So to find that, we're going to multiply the number of games by the probability of that. Okay, so this is 20 over 27 plus, and 5 times 5 is 25 over 27 plus 6 times 6 is 36 over 27 plus 7 times 11 is 77 over 27. Now I would divide this by the sum of all these, but the sum of all these is 27 over 27. Sum of the probabilities, and that's just 1. So really all I need to do again is add the top, 158 over 27. What that gives me is 5.85. What does that mean? What does this number represent? This is the expected value of the number of games played. So if we were having a World Series next year, I could expect 5.85 games. That means usually you can kind of say there's going to be between 5 and 6 games. Also, looking just at their probabilities, the probability is high that there's 7. But we also kind of have to weight that with the fact that sometimes there's 4. And so that brings down the average, or the weighted average, or expected value, to be 5.85 games. So it's not a percent because, but it's basically giving you a number that's going to be in this range of where you think you should land. Let's do one more to explain that a little bit better. So the probability distribution of the number of accidents in a week at an intersection based on past data is given below. Find the expected number of accidents in a week. So the probability of 0 accidents occurring is 0.75. So it's a really high chance that there are going to be no accidents. But I can't expect no accidents because sometimes accidents occur. So even though it has the highest probability, I'm not going to expect 0 accidents. I'm going to expect maybe there might be one that week. So I want to know what the expected value is. So to do that, we're going to multiply these. And so when you multiply 0 by anything, you get 0. We're going to multiply these, 0.15. Multiply these, that's 0.16. And multiply that is 0.06 divided by 1 again is 0.37. That is my expected value. In this case, it's my expected number of accidents in a week. So I can expect 0.37 accidents. Now, obviously, there's either 0 or 1. Not very likely that we're going to have 3. So maybe that helps explain that a little bit. All right, there will be a second video for lesson 8.1a, and then the next lesson will be 8.1b.